to the new, what we call shuttleless weaving systems, of which there are 4 types. There is a projectile, air jet weft insertion, water jet weft insertion, and rapier weft insertion. Yeah? You possibly don't know that woven fabric consists of 2 sets of yarns, warp yarn and weft yarn, and they're interlaced normally at 90 degrees to each other. And I say normally because we are certainly working on, and there's other companies, etc., working on what we call 3-dimensional weaving, which basically brings into play a 3rd dimension. Okay? What that means basically is you put a yarn going through the fabric also. Okay? Warp yarn always runs the length of the fabric, weft yarn always runs the width of the fabric. Okay? Warp yarn is contained in this instance on what we call a warp beam, which feeds the warp yarn into the loom. This is a shuttle weaving machine. Therefore, the weft is inserted across the width of the fabric by use of a shuttle. These are the old systems. Yeah. And inside the shuttle we have a perm which contains a weft yarn. And it's through this shed that we insert the weft. Whichever method of weft insertion we're using, it's exactly the same. Yeah? Because basically, methods of weaving haven't changed for centuries. Even when it was hand loom weaving, we still created a shed, and they used a shuttle to insert the weft, but it was done by hand. Okay? So the basics haven't changed. So what you'll see as I flip this loom over, you'll see these heel frame positions change. Now all these warp ends are drawn into are controlled by one of these heel frames. Yeah? And that's what forms the shed. So when a heel frame goes to bottom shed position, all those warp ends that are controlled by that heel frame will go to bottom shed position, etc. And this forms the shed so we can insert the weft. So what you'll see the heel frame positions change, and the shuttle will go from left to right through the open shed, inserting the weft, and then back again. Developed in order to increase productivity, and the projectile was the first one to be developed. And what we have with the projectile, instead of a shuttle carrying the weft, we have a projectile. So we can see how things have improved immensely just there. And in the projectile we have what we call a weft gripper, which can be opened and closed. And it's this weft gripper that grips a weft directly from yarn package and carries it across to the other side. Now, as you saw on the shuttle weaving machine, the weft is inserted from both sides of the machine. The shuttleless weft insertion, they're always inserted from one side of the machine only, and directly from yarn package. So basically, when these shuttleless weaving was developed, not only did it increase machine speeds, improve fabric quality, it also cut out one process, which was the winding of the perms. Okay. So it had benefits, monetary benefits all round. And currently projectile machines will insert round about 500 weft insertions per minute. This is a rapier weft insertion system, and basically what happens with this is the weft is taken halfway across the machine by this left-hand rapier, and then in the centre the weft is transferred to the right-hand rapier, as you can see, and the second half of weft insertion is taken by the right-hand rapier. On this particular rapier machine, the shedding mechanism we use for driving the warp yarns up or down is what we call a Jacquard. And the big advantage of Jacquard systems is that you can individually control each warp yarn. Whereas on the other systems, as you saw, we had heel frames going up and down. So therefore, every end that was controlled, let's say by heel frame number 1, if heel frame number 1 is lowered, then every end controlled by heel frame 1 is lowered. But with this system, we can individually control every warp yarn. This Jacquard is electronically controlled as opposed to the mechanical systems that used to be about. Now, using the CAD system with the electronic controller has reduced the design times by weeks. Yeah? Because a few years ago, the Jacquard would be controlled with punch cards. Yeah? And punching, depending on the complexity of the design, punching the card to the correct lift and lower, or the correct shedding, as we call it, could take weeks. Whereas now, it could be done in hours, maybe a couple of days, like I say, depending upon the complexity. Right. And then again, on that small sheet there, we've got some ballistic fabrics going in there in a couple of weeks' time. Ministry of Defence, automotive, etc., etc. Currently, I've got a project going on in there that's medical textiles for a medical company in the UK. On the machine here, we're looking at